quite a common question to turn up. Evaluate 2 1/3 plus 4/5. So the first thing I'm going to do is do my third plus my 4/5. 3 times 5 is 15. So that's my common denominator. 1 times 5 is 5 for the first fraction. 4 times 3 is 12. Putting it together, I get 12 plus 5 is 17 over 15. Changing it back to a mixed number, I get 1 and 2/15. Because 15 goes into 17 one time with 2 remainder. So the answer to the question, I've got 2 remember. So I've got 2 plus 1 and 2/15, which means I've got 3 and 2/15. So again, remember, the other way you could have done this question is to change the 2 1/3 into an improper fraction and then added and simplified. SQA National 5 Maths 2018 Paper 1 Question 2, expand and simplify. Well, I always use the box method for this, so I'm not going to stop now. So I've got one set of brackets on one side, 3x plus 1 times x minus 1. So I'm going to expand and simplify that. And then it's plus another box, 2 on one side times x squared minus 5 on the other. So I can now easily expand it using a different colour to highlight the answers. 3x times x is 3x squared. 3x times minus 1 is minus 3x. 1 times x is plus 1x. 1 times minus 1 is minus 1. So there's my first set of answers. And then over in the other box, 2 times x squared is 2x squared. You might want to put a plus. And 2 times minus 5 is minus 10. And then taking our answer outside the box in. Collecting like terms, so looking at our x squared, we get 3x squared and 2x squared, so that's 5x squared. Looking at our x terms, being careful, we've got minus 3x plus 1x is minus 2x, nothing on this side, so it's minus 2x. And looking at our number parts, we've got minus 1, minus 10, so that gives me minus 11. And I'm done there. So 5 Maths 2018 Paper 1 Question 3. Solve algebraic with a system of equations. So as you see, it's the same thing over and over again. We'll just solve them by the same way, make the x's of the y's the same. So in this time, I'll make the y's the same again. So I'm going to times this one by 2 and times this one by 5. This will give me 10 for both of them. So that gives me ax plus 10y equals minus 6. 30x minus 10y equals 25. The signs in front of the y's are different, so I can add the equations. I'll just put an add here. 38x equals 25 take away 6, which is 19. So x is 19 over 38. Always simplify your fractions. 2 19s is 38, so that's just a half. And now we substitute into any of the equations we've got to get our y. The top one, remember, was 4x plus 5y is minus 3. So x is a half, so I've got 4 times a half plus 5y equals minus 3. A half of 4 is 2. Plus 5y equals minus 3. So 5y is minus 5. So y is minus 1 for our second answer. And we're done there. SQA National 5 Maths 2018 Paper 1 Question 4 on vectors. 2 vectors are given by u is 1, 5, 1. U is 1, 5, 1. And u plus v is 6 minus 4, 3. So u is this one plus some v, which we don't know, equals 6 minus 4 and 3. So we're just working backwards. So if we're starting at the answer, 6, take away 1, we'll give this one 5. That means 5 plus 1 is 6. Minus 4, take away 5 is minus 9. Doing the opposite of plus. 5 minus 9 is minus 4, just a quick check. And then 3, take away 1 is 2, just a quick check. 2 plus 1 is 3. So we're done. Just to write our answer out at the side, v is 5 minus 9 and 2, and we're done there. Solving quadratic equations by factorising SQA National 5 Maths 2018 Paper 1 Question 5. Solve x squared minus 11x plus 24 equals 0. So you should recognise that's a quadratic or trinomial because it's got an x squared, an x and a number. So since it's paper 1, I know we're factorising most of the time because if we use the quadratic form, we're going to get decimals. So unless it tells us to in paper 1, factorises. Looking for a common factor, there's no common factor, so straight away it is double brackets. And this is quite a simple one. If it's just an x squared, I can write x and x straight away. To get my other numbers, I'm looking for two numbers at times to make 24, but add to make minus 11. So at the side, what you could do is write minus 11 and 24. Writing down all the factor pairs of 24, so 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I'm done. And you're looking for those pairs, can I add or take away to make minus 11? Well, I clearly can't do that with 24 and 1. I can do it with 12 and 2. No, can't do it. Can I do it with 3 and 8? Well, 3 plus 8 is 11, so yes, I'm going to be able to do it. And can I do it with 4 and 6? Nope. So how do I do it with 3 and 8 to make minus 11? Well, I need minus 3 and minus 8 to make minus 11. And just double check at the end, minus 3 times minus 8 is 24. So I've done it right. Minus 3 minus 8. So we've got two brackets that equal 0. That means that x minus 3 equals 0 or x minus 8 equals 0. And just solving those equations, x must be 3 because 3 take away 3 is 0, or x must be 8 because 8 take away 8 is 0. And we're done there. Question 8, National 5 Maths 2018, paper 1, question 6 had part of the graph of k a cos bx is shown. Find the values of a and b. So again, checking its maximum and minimum, it goes from 5 to minus 5, so that's a span of 10. Half of that is 5, so a equals 5 for our amplitude. And then to get our b is bx, so it's the number of waves up to 360. So be very careful but don't try and trick you. There's 1, 2, so you'd be tempted to write 2, but looking at this number is 180. So it's going to go up another 2 to 360, so it's actually 4. SQA National 5 Maths 2018 paper 1 question 6 for line of best fit. The graph, the cost of a journey for Tom's taxis depends on the distance travelled. The graph below shows the cost in pounds for P for a journey in Tom taxis and distance D. A is this point and B is this point. Find the equation of a line in terms of P and D. Give your equation in simplest form. So it's always the same straight line. We need gradient, then we need to use a point for y minus b equals mx minus a, and then we swap the y and the x for P in this case and D. And then part B, look at cost of journey of 5 miles. I substitute 5 in and see what I get. So part A, our points are 8 and 14 and 12 and 20. So that's my x1 and y1, and that's my x2 and y2. So my gradient is equal to 20 minus 14, y2 minus y1, over 12 minus 8, x2 minus x1. 20 minus 14 is 6, 12 minus 8 is 4. So you get 6 over 4, and you get a mark for getting that far, but I'm going to simplify that right now to 3 over 2, because you can divide top and bottom by 2. Now we use y minus b equals mx minus a, where a and b is just one of the points. I'll just pick the first one, a and b. You could pick the other one. So I get y minus 14 equals 3 over 2 x minus 8. Y minus 14 equals 3 over 2x. 8 divided by 2 is 4. 4 times 3 is 12. So minus 12. Y equals 3 over 2x plus 2. And then swapping in our P and D. P was y-axis and D was x-axis. So we can write in the end P equals 3 over 2 times D plus 2. Now notice in this case, usually at this point if I had a fraction, I would times through, but I want to really have P equals to work out the cost. So it's much easier in this case to leave the fraction in, but you might want to take the fraction away and put it back in if you want. Okay, part B says calculate the cost of a journey of 5 miles. So D is 5. So I can just do for part B, D equals 5. So P equals 3 over 2 times 5 plus 2. So that is 15 over 2 plus 2. which is 7.5, plus 2, which is equal to 9.5. So the cost, P, equals £9.50. Don't leave your answer as 9.5, that's not money. So you need to get £9.50. Using the discriminant, SQA National 5 Maths 2018, paper 1, question 8. Determine the nature of the roots of the function f of x equals 2x squared plus 4x plus 5. If it mentions the nature of the roots, you're using the discriminant, which you'll get from the start of the exam paper. If you look at the quadratic formula, the bit under the square root sign is b squared minus 4ac. That's called the discriminant. So our A is 2, our B is 4, and our C is 5. Signs are important. So b squared is 4 squared minus 4 times 2 times 5. That's 16. 4 2s are 8, 5s are 40. 16 minus 40 is negative 24. And then we need to write a little statement. And the statement is always since b squared minus 4ac, this one is less than 0, there are no real roots. There are two options when you do this. If you get 0, there are 2 equal roots and 2 real equal roots. And if you get a positive number, there are 2 distinct real roots, 2 different real roots. Okay, right, there we go. SQA National 5 Maths 2018, paper 1, question 9 had this one, and it says the diagram is a regular decagon. You can count that. It's 10-sided. Okay, it's 10-sided. And it says KGL here is 17. You've got a straight line, A, K, and L. Calculate the size of KJL here. Okay, so we're going to have to do some work to get the angles. We're going to need to know this angle here. But all these triangles are the same. And since that's around a point, I can just do 360 divided by 10 to get 36 in the middle. So I know that that's 36 here, and that that's an isosceles triangle. So 180 minus 36, it's paper 1, so you just need to do it with a calculator to get 144. 144 divided by 2 gives you 72 degrees. So we get 72 here and here, but since all these triangles are exactly the same, that means that that one's also 72. And now we've got angles on a straight line up to 180, so these two make 144, and I need to take that away from 180, so I get 36 back down here. And now it's pretty simple. Angles in a triangle add up to 180, so I do 36 plus 17 away from 180 is 127. So our answer is 127 degrees for our final mark. You get a mark for getting 72 and 72, or for getting 36 down there, then you get a mark for the 127 at the end. By Maths for 18, paper 1, question 10. So this is a non-calculator. It says side x, z is 10, zy is 8, cos z is 1/8. Calculate xy. So it tells you the cos of z instead of the angle, so you don't have to work it out. But it's still cosine look, I've got two sides and the angle in between to find the opposite side. So if I just call that my A and that my A, I can just change that to an A. So then we've got A squared equals B squared plus C squared minus 2BC cos A. Substituting in, that is 10 squared plus 8 squared minus 2 times 10 times 8 times, well, the cos of A is 1/8. Non-calculator, so you're just going to have to do some non-calculator work on this, I'm afraid. 10 times 10 is 100. 8 times 8 is 64. Luckily, I've got 8 times an eighth, so that's 1. 1 times 10 is 10, times 2 is 20. So take away 20, which gives us a final answer of 144. But remember, that is A squared. So A is the square root of 144, which is a nice round number, which is 12 centimetres, because 12 times 12 is 144. Okay, 2018, paper 1, question 11. Express 9 over root 6 with a rational denominator. So we start with 9 over root 6, we times by root 6 over root 6. So this gives me 9 root 6 on the top over just 6 on the bottom. I can simplify the number parts by dividing by 3. 3 goes into 9 3 times, 3 goes into 6 twice, leaving 3 root 6 on the top and 2 on the bottom for our final answer.
It's great National 5 Maths 2018 paper 1 question 12 on trig equations. Given that cos 60 is 0.5, state the value of cos 240. The only way to ever do these questions, well, I suppose you could use a graph of a cast diagram. So you draw a cast diagram. It's saying cos 60, which is in this quadrant, so that's our 60 degrees. So in this quadrant is 180 minus, which is 120. 180 plus 60 is 240, and 360 minus 60 is 300. It wants us to work it out here, but in that value the cos is negative, which means the cos of 240 is the same number, 0.5, but just minus. And we're done there.
It's great National 5 Maths 2018 paper 1 question 13 on 3D coordinates. It shows us this picture. It tells us that A to D is equal to A to E. So in other words, this side is equal to that side. So we can take a note of that just by putting little dashes in, just to remind us later. It says that DC is equal to 8. So there's D to C, there is 8. And it says that we've got edges EF, DC and AB parallel to the y-axis. Write down the coordinates of B and C. So let's work out how we get to B. Well, if we start at 0, 0, we always start, we need to go along, and that'll be in the middle of the shape, because if you see B here is in the middle here, so I need to go along to the middle of the shape, then down the y-axis, and then up high. So I just need to work out these 3 lines. So let me draw them in. I need to go along to here. Well, how far is that? I've went along 2, and then if you notice the difference between these coordinates is 2, so that means I went along another 2. So I went 2, 4. So I can write B equals 4. Let me just note that for you. I then went in this far. Well, we already know that this line here is 8, so it's the same again. That is 8 in. And then I need to go all the way up the shape. So we need to know how high that is. Well, let's check if there's any other coordinates that tell us that. If we look at A, 4, 0, 5, 5's the y-axis, so 5's the height there, so 5's the height there. So I can just say I'm going up 5, so I've got 4, 8, 5 for B. We can do the same for C, so let me use a different colour so you can really see that. So I need to work out how to get to C, so again I'm going along all the way to D, then I'm going all the way in to C, but then I'm not moving, so I already know that Z is going to be 0. So let's just work out along the way first. I need to jump all the way along here. So how far is that? Well, we already know that that goes 2. And then that goes another 2, that's 4. Symmetrical makes 5, 6. So that line there is 6. Then I go in this way, which we already know is 8. So we've got 6, 8. Then I don't move from that point, so 0. 6, 8, 0. Is my final answer. Paper 1, question 14. Change the subject of the formula to x. But again, we've got a root involved. Now, when it's a root, but if there's other things in the question, it's sometimes better to make the root the subject and then square at the end. It just eliminates any problems you're going to have. So, I'm going to make the root x the subject. So I'm going to take away h to start with. So y minus h equals g root x. Dividing by g, we get y minus h over g equals root x. And now, since we've eliminated everything and we've got root x on its own, we can just square both sides. So we can just write a big bracket, y minus h over g squared. The whole thing's getting squared, equals x. And we're done. Laws of Indices, SQA National 5 Maths, 2018, paper 1, question 15. Remove the brackets and simplify. So we've got 2/3 p to the 4 squared. So this is your power rule. So remember, we looked at this already. We can take the 2/3 and that gets squared as well. And then the p to the 4 has to be squared, but we can use the power rule. 4 times 2 is 8. So it simplifies to that to start with. But then we need to work out what 2/3 squared is. Well, that's 2/3 times 2/3. So I can square the top, which is 4, and square the bottom, which is 9. And I've got p to the 8. And we're done there. This fraction is simplified. Screen National 5 Maths 2018, Paper 1, Question 16. Sketch a graph of y equals x minus 6x plus 4. On this sketch, show the points of intersection with the x and y axis and the turning point. Okay, let's do our points of intersection first. So it cuts the y-axis when x equals 0, the other number, the other letter. So when x equals 0, we get 0 minus 6, 0 plus 4. So that's minus 6 times 4, which is minus 24. So it cuts the y-axis at 0 minus 24. There's our first thing. It cuts the x-axis when y is 0. So it cuts the x-axis when the other letter y equals 0. So subbing that in, we get x minus 6, x plus 4 equals 0. Well, that's already factorized, so we can now just solve that. That means that x minus 6 equals 0, so x equals 6. And x plus 4 equals 0, so x equals minus 4. So we've got our 2 points along 6 up 0 and minus 4, 0 as well. Now, the turning point is interesting. There's a couple of ways to do it, but the simplest way is to realise that the turning point happens in the middle of the 2 roots, where it cuts the x-axis. So I want the middle of 6 and minus 4. So for my turning point, all you have to do to get the middle is add up 6 and minus 4, 6 plus minus 4, and then divide by 2. So 6 minus 4 is 2, divided by 2 equals 1. So x equals 1 is the turning point. I now need the y, but we know y is x minus 6 and x plus 4. So y equals x minus 6, 1 minus 6, and x plus 4, 1 plus 4. 1 minus 6 is minus 5. 1 plus 4 is 5, that equals minus 25. So our point is 1 minus 25. We've now got our turning point where it cuts the x and y axis, so we can just draw a nice quick sketch. X and y. So we've got along 1 down minus 25, which is labelled at 1 minus 25. It cuts the y axis at minus 24, so let's just say there at minus 24. And it goes through 6 and minus 4. So minus 4 over here, 6 over here, try to make it as symmetrical as I can. And then just a nice curve. Try to make it as neat as you possibly can, but there you are, that's good enough.
Another volume question, SQA National 5 Maths 2018, Paper 1, Question 17 had this one. A square-based pyramid is shown in a diagram. The square has a base length of 6 and the volume is 138. Calculate the height. So this is a working backwards volume question. So math stages, there's a few ways you could do this, but math stages is always to write down my formula, then work backwards. So from the start of the exam paper, the volume of a pyramid is 1/3 times the area times the height. Okay, so substituting everything in, I've got 138 on this side equals 1/3 times, now it's a square, so it's 6 squared or 6 times 6. I'll just write 6 squared times the height. Stage we can do 138 equals 1/3 of 36 times h. 138 equals, well, 3 into 36 goes 12, so that's just 12h. And then we can work out h. 138 divided by 12 is equal to 11.5 centimetres. And that is one of the simplest ways to work it out. You could have also just made h the subject of the formula and worked it out, but there you go. Screen Rationalise Maths 2018, Paper 1, Question 18. Express sin x, cos x, tan x in its simplest form. We've got a sin x and cos x, so we'll eliminate the tan x by changing the tan x into sin x over cos x. So we've got sin x, cos x times sin x over cos x. And then we can cancel some fractions. So cos x cancels with cos x. That just leaves us with sin x times sin x, which we can write as sin squared x for our final mark.
Okay, completing the square and the quadratic formula. SQA National 5 Maths 2018, Paper 1, Question 19. Quite a big one this. Part A, express x squared minus 6x minus 18 in the form x minus p squared plus q minus p squared plus q or minus a squared plus b, completing the square. Then state the axis of symmetry, which we'll get to, and the roots of this can be expressed in this form. Find algebraic D and E. So this is a quadratic formula question in a paper 1. We've expressly put it like that because that's what it looks like at the end or before you've got your answer. So let's go through this step by step. Question A. I've got x squared minus 6x minus 81. So to complete the square, I go like 1 bracket squared, x minus half the middle term is 3. Now, how do I get my numbers on the end? Well, I immediately take off that number squared. So the number is take away 3 squared, technically minus 3 squared. Then you're going to still take away 81 because that's hanging around on the end. So that gives me x minus 3 squared. 3 3s are 9, so it's take away 9, take away 81. Because I'm over by 9 basically. So that gives me x minus 3 squared minus 9 minus 81. That's minus 90. And we're done there. Part B, 10 state the equation of the axis of symmetry. When you complete the square, we don't do it for nothing. It tells us something. It tells us the turning point. The turning point is this number here and this number here. That sign changes. So if it's minus, it becomes positive. Positive becomes minus because you're making this bracket 0. So my turning point is 3 minus 90. I'll just write that down. My turning point, which we may ask you in some questions, is 3 minus 90. When you draw a quadratic, it is symmetrical at the turning point. So when they ask you for the axis of symmetry, we're just asking you for x equals 3 because it's a vertical line, so x equals the number. Where does 3 come from? The turning point. So that's all we're asking you there. Part B says, the roots of the equation x squared minus 6x minus 81 equals 0 can be expressed in the form x equals d plus or minus d root e. Find the values of d and e. There's 2 ways to actually do this. You can start from completed square form, or you can go back and use the quadratic formula. I think most people will use the quadratic formula rather than the completed square form, so I'm going to do it that way. But just be aware you can do it the other way. So let's start off with x squared minus 6x minus 81 equals 0. If we look at the start of the exam paper, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So our a equals 1, the number in front of x squared, our b equals minus 6, and our c equals minus 81. X equals minus 6, watch there's a minus and a minus there, plus or minus the square root of minus 6 squared minus 4 times 1 times minus 81 all over 2 times 1. So watching out for minuses. Minus 6 is positive 6, plus or minus the square root of 6 times 6 is 36, minus times a minus is a plus. 4 times 81, well, you might need to do that sum at the side, but if you have to, just do this. 4 1s is 4, 4 8s is 32. So that, and it's a minus times a minus, so it's a plus. So it's plus 324. 2 times 1 is 2. We have to get it down to d plus or minus d root e. So x equals 6 plus or minus the square root of 324 plus 36. So that's 324, 330, 360 over 2. Well, 360 is like a third, yeah? You may not know if it's an exact square root, but we can work it out as a third because we can do root 360. 2 numbers at times together to make that, well, 36 and 10. So that means you get root 36 is 6, root 10. Now, root 10 can't be simplified further, so I can change my root 360 to 6 root 10. So x equals plus or minus 6, plus or minus the square root of 6, root 10 over 2. So that means that x equals, dividing the first thing by 2, I get 3, and the second thing by 2, I also get 3 root 10. And we're done there.